Yesterday, we started discussing about what is Helm, how to install Helm, and how can we install the applications using Helm. We created one Helm chart for our application. Yesterday, we deployed one application using Helm chart. We created our own Helm chart. So if you see, we created one Helm chart. This Helm chart contains, basically, we created a Helm chart. This contains some standard directory structure. Where we have our manifest files in a templates folder, where we have our manifest files in a templates folder. We have a deployment.yml, hpa.yml, right? ingress.yml, and there are values which will control. We can pass these values at runtime. So these values has been referred. These values has been referred as part of the manifest files. As part of the manifest files, these values has been referred. If required, we can play with these values. And if you see, this one we deployed yesterday. Helm maintains the version, Helm will maintain the release information. Whatever application we deployed using Helm, we call it as a release. This release information will be maintained in a Kubernetes cluster. So if I want to upgrade this Helm chart, we can upgrade. If you see, as of now, this Helm chart has created a deployment. So this deployment is created from some image. So this deployment is created from this version of the image. Now, if I want to update this, right, I can update using this Helm chart itself. Now, suppose I want to upgrade this one, right? We have a command Helm, upgrade, Helm, upgrade. Our Helm release name, whatever we have created when we install the Helm chart. Then -set. This is where our charts are there. Inside this, our charts are there. Our Helm YMLs. I can install, I can upgrade from a local directory, Helm chart local directory. This is Helm chart local directory. And I can change my image, something like this. We have a values file inside this one, image.tag equals to 2, something like this. Now, if you see, it is getting updated. Now you can see the image. If you see the deployment, right, there are two histories now. Just now, we are updating. We are updating our application using Helm chart. We are upgrading. These values we can pass at runtime, which are part of our values file. We no need to modify values file also. We can pass at runtime also. Now, if you see, this is my image tag, image version. Helm is trying to upgrade the application which is running in a Kubernetes cluster. If I want to change some other value also, I can change at runtime, or I can modify the values file and I can apply. Now, if you see, if you see, the deployment is getting updated inside internally, right? And if I see Helm LS, right? Helm also maintains the release information. Helm also maintain the release information. If you see, as of now, this is the version, this is the revision, Helm revision. Now, if something went wrong with this application, if something went wrong with this application, if I have to revert, if I want to roll back, what can I do? Using Helm chart, I can do something like this. Helm rollback, something like this. Just Helm rollback. Your just your chart. This is your release name, something like this. Now, if you see, it is getting rolled back. It is going to the previous state. It is going to be to the previous state. It is going to be the previous state, old version of your image, right? Using Helm, we can install, we can upgrade, we can roll back our applications using Helm, right? As we discussed already, Helm simplifies the process of installing, basically, I mean to say deploying, upgrading, and deleting applications in Kubernetes. Applications in Kubernetes. So now we have this Helm chart. We have this Helm chart locally. So if I maintain this directory, if I maintain this one as part of CI/CD, like as part of GitHub, I can maintain this chart in our project. Suppose I want to maintain, I can maintain something like this in our project. As part of this, as part of this project, I can maintain that folder, that Helm chart also in the GitHub, something like this. Let me clone. Something like this. some folder, something like this. So inside this, I have copied this Helm chart. Let me go inside this. Now we are maintaining this Helm charts also. Now I no need to maintain something like this, lot of files. Okay, I no need to maintain something like this. Inside this chart, I have everything, and I can play with values also. So I can maintain this one as part of our source code, so that these can be used in your CI/CD to deploy the application, right? Now, the Helm charts also basically part of this source code. The Helm charts also part of this source code. Yeah, as part of our CI/CD, I can clone this one. I can do something like this as part of our CI/CD. We can first clone this project. Then we can build the project as part of your CI/CD. You can build the project. Then you can build an image, your image, whatever repository you want to push. With your build number. Then you can push an image. Then you can push this image after authenticating. Then when it comes to the deployment in your CI/CD server, if you have a Helm installed and kubectl configured, you can do something like this. Helm install Java web app. As part of the source code itself, you have this folder, right? Then you can pass something like this. You no need to touch any file. At runtime, you can pass whatever values you want to pass. Something like this. So inside this, you have that folder, right? Inside this, you have a folder, this folder. So you can play with these values file at runtime. As part of your CI/CD, you can have all these stages so that which can be deployed. Or if you want to upgrade, you can use Helm upgrade. Whatever you want to set. I'm just giving one value, right? If you want to, suppose you are pushing to a different, something like this. In your CI/CD, you have something else. Maybe you are pushing into some different, something like this, different repo. Your Docker repo, right? Something like this. You are pushing to some repository. So this one you are using I'm just giving an example. You are creating an image with that repository. You are pushing something like this. And here you can set that one also, what from which, we have a values file, right? In values file, there is a value. We can pass multiple values, something like this. So we can install the applications, we can upgrade the applications, we can roll back the applications using Helm. So if you want to maintain as part of CI/CD, if you want to maintain as part of your source code, you can maintain the Helm chart, something like this. And you can use these Helm commands as part of your CI/CD pipeline to install the applications, right? Suppose if I am not using Helm chart, I have to have a lot of I mean to say I have to apply lot of YML files. I need to update YML files based on the build number or based on the version of the image which I want to deploy. But Helm simplifies the process of installing, upgrading, and deleting the applications in a Kubernetes cluster. There is one more option. You don't want to maintain something like this as part of GitHub as a source code. What is the other option we have if you don't want to maintain something like this? If you don't want to maintain as part of the source code, right? There is another option. You can create a package, Helm package as a tar file. That package can be maintained as part of Helm repositories. As part of Helm repository. So let me show that. I can create a package instead of maintaining something like this, right? What you can do? You can create a tar file out of this. You can create a tar file out of this package that we can maintain in a Helm repositories. Like you can use Nexus or you can use JFrog, or there is a way we can maintain in a GitHub also as a Helm package, Helm chart. So let me show that. Now, suppose you are not let me take it out. Now you are not, you don't want to maintain as part of your source code. You created a chart. You created a chart. You created a chart. You updated all your values. You updated all your values, right? The default values which you are referring, right? The repository, tag, whatever you want to use, whatever you are using in Helm chart. So you updated your values file, you modified your templates based on your requirement. You have added, you are modified your Helm chart templates based on your requirement. Then I can create a package out of this folder, Helm chart. This is how I can execute. Before that, I can validate whether Helm chart is proper or not. I can do some kind of a syntax check. I can do a syntax check using this command, Helm lint. This is your chart name, your folder name. You created a Helm chart, right? So I can validate something like this, Helm lint this. So if there are any syntax issues, I mean to say the templates are not proper, then it will fail. So chart is valid. Now I can create a package out of this folder. So when I execute this one Helm package, if you see, the tar file got created out of this one. So what is there inside this tar file, guys? What will be there inside the tar file? All these files. Helm chart, Helm inside tar files, all the files, whatever we have as part of this chart. I can use this tar file also to install. I can use this tar file also. The way I have used folder, I can use this tar file also, something like this. Helm. If I already have a application installed, I can upgrade. Helm upgrade the release name. I can use this chart, this tar file. Something like this. You can use this tar file also. The way I have used local folder, I can use this tar file also. But when I am working with the team, is it a better idea to share the tar file or folders between the team with each other over the mails or over the mails, or can I manually share this folder or tar file, or is there a better way of maintaining this chart? What can I do? I can maintain in a Helm repository. I can maintain this chart in a Helm repository. Whoever is required, they can add the Helm repository and they can install the application. So now I just created a chart file. I created a package. What I can do? This one, we can add it to the Helm repository. You can add it to the Helm repository. Guys, you can create a Helm repository. Like if you are using Nexus, JFrog, there also you can create a repository, Helm repository. The way we are creating repositories for maintaining Docker image, the way we are creating repositories for maintaining Java packages. Similarly, we can create a repository for managing the Helm charts, Helm packages. Or I can use GitHub also as a Helm repository. But GitHub not as a source code repository. I should not check in this tar file as part of your source code, something like this. I no need to, I should not copy and I should not check in something like this. I have to first create a pages, GitHub pages to maintain this Helm repository. Now we can publish this Helm package to our GitHub repository as a GitHub pages. As a GitHub pages. Okay. So what I can do, I can create a GitHub repository, or I can maintain as part of this one itself, but not as a source code. I will check in as part of this source code, but first I need to create a GitHub pages URL to create a Helm chart, to maintain the Helm chart in the source in this GitHub. I can maintain as part of this one, but I need to create a pages, GitHub pages URL. Maybe you can go to this settings file. Here we have some option. pages, GitHub pages. So first we need to create a GitHub pages. Select the branch on which branch you have to create. So we need to create a GitHub pages URL. Click on save. It will give one URL. This is what I need. This URL is required now. If I want to maintain in GitHub this chart as a GitHub, has a Helm repository, I need to create this GitHub pages URL where I can maintain some files. This is required. So what I have done, I have taken this, I have created a GitHub pages in this repository. This URL is required to maintain the Helm chart. GitHub pages URL. Once you create a page, you will get this one. Take this one. Then what I can do? Next, I created a GitHub pages. And if you have created a new repository, first create a repository, and clone that repository. First create a repository, create a GitHub page, and clone that repository. I have already have a repository. I have created a GitHub pages on that repository. I already cloned. Now, what I will do? I will move this tar file inside that GitHub repository again. Now I have cloned this one. This is my GitHub. I have cloned. What I will do? I will move this tar file inside that one. Something like this. This tar file. Inside this GitHub project. Something like this. Guys, in this document, what I have shown, I first created a new GitHub repository. I have created a GitHub pages. Then I cloned that one. Then I moved the tar file to this one. But I already have a repository. I have not created a new repository. I just created a GitHub pages in the existing repository. I am copying the tar file to the GitHub source code. So now, as part of this, I have this one, the tar file. I moved that one. Then we are going to generate one index file for a Helm repository. So I need to execute this command, Helm repo index. This is my GitHub folder name, GitHub project name. In current case, this is my GitHub repository name. This URL is nothing but the pages URL, whatever you have created. This URL is nothing but a pages URL, whatever you have created, GitHub pages URL. Here you have created, right? So this is basically our Helm repository URL. So when I execute this command, if you see, as of now, inside this, these are the files I have. Now when I execute this command, it will generate one index.yaml file. Inside this folder, it will generate one index.yaml file. If you see now, it has generated one index.yaml file. What is there in that index.yaml file? This is required. So this file we have generated. What is there in this YAML file? By looking at this, what can you understand? Basically, it is our Helm repository information, Helm chart information. This is the chart name. This is the version. This is the description of that chart, right? And where exactly that chart is maintained, where the tar file is there. The Helm chart information. So this is required. Now, once you generate this index.yaml file, go inside the GitHub project, go inside the GitHub project where you have a index.yaml, where you have a your chart tar file. But while generating this index.yaml, right, we should not use our GitHub URL. We have to use GitHub pages URL which we created. Then go inside and commit the code. Helm package. Now, let me push the code. Now, if you see, as part of source code, we are maintaining the tar file, but I can use now this GitHub pages as a Helm chart repository. Now I have a tar file, I have index.yaml, the Helm related files. Now I can use this, not this URL, guys, not this one. I can use this GitHub pages URL as a Helm chart repository, this URL. This is my Helm repository now. Let me come outside. Let me remove. Now I can add this one as a Helm repository, this GitHub pages URL, whatever I have, right? This one I can add it as a Helm repository. Something like this. Helm repo add, I can add something like this. This GitHub pages URL. Now if you see, I have added this one as Helm chart. Now when I search Helm, search repo, when I search in this repo, how many charts I can see? How many charts I can see? If you see, there is one chart. Now I don't have the files locally, that Helm chart. I am maintaining that in a Helm repository. Now if I want to install or if I want to upgrade, I can do something like this. Let me remove this one and I will install from the directory from the repository. Helm. Let me remove this Helm uninstall. Helm uninstall. Now I don't have the Helm chart locally. If you see, I don't have that folder or tar file. I have added a Helm repository. Now I can install something like this. Helm install Java web app, my chart name. What is my chart name? Right, this is my, let me search the repo, then I will come to know. Helm search repo. So this is my chart name. So I can install the application something like this. Helm install. I need to give a name for this application. We call it as a release name. If I want to customize some values, can I customize the values, guys? Now values file is also part of this one. If I want to see the values before installing, if I want to see the values, I can use this command, helm show values. If you see helm show values, this is my chart name. These are the values which we have defined in a values file. If you want to override values while installing something, if you want to override a single value or multiple values, you can pass something like this. Suppose now if I want to change image version, I want to install version 2, right? I can do something like this. Helm image dot tag equals to 2, something like this. Helm install something like this. So values I can change at runtime for this chart. If I want to change some other value also, I can change using this hyphen set, right? I can change whatever I want to change. If I don't set the values, what value it will use for that one? Whatever is there in your Helm chart, right? If you have to modify lot of values, there is a one more option. If you have to modify lot of values, what you can do, you can take something like this, show values. It will display the values. You can append it to one file. You can take those values, something like this, whatever way you want to take. Extension can be anything, something like this. So I have taken all the values from the chart. I can modify this values file based on whatever you want to change, right? You can modify something like this, right? If you want to modify something, instead of cluster IP, suppose you want to create something else, something like this, node port. If you want to enable ingress, you can enable ingress and you can define whatever you want to define. Path, host, right? Something like this. Host is Mithun Tech DevOps.co.in path, right? Your path, whatever path you want to give. Something like this. Whatever values you want to modify, right? Suppose if you want to enable auto scaling, you can make it true. minimum replicas, maximum replicas, right? And if you want to enable the resources, right? Resource limits, sorry, this yeah, resource limits and request, right? If you see, I can uncomment this one. Now I can define here whatever at runtime, right? If I want to deploy this application, so with all these options, where are we referring all these values, guys? Where are we referring all these values? Where are we referring all these values? Inside the file, our Helm chart. Now, if you see, I have just taken the values. Did I taken the chart locally? Am I modifying the templates? Or I am just playing with my values at runtime based on the requirement? Am I modifying my templates, the YMLs, right? We are just playing with the values, right? Now, how I have taken the values? I have added a Helm repository. I have added my Helm repository. This is our repository. Inside this Helm repository, I have this chart. Helm search repo search. Let me search repo. Helm search repo. Mithun Tech. As part of this, I have this chart. I have taken a values. I have taken this values something like this. Helm show values. This chart name. So these are the default values. These are the default values. What I have done, I have taken something like this, the values. Then I have updated this file based on the run, based on whatever I want to deploy it, whatever I have to change. I have changed in this values file. If you see now, I have done a lot of things. I have enabled auto scaling. I have set the limits and request, and I have given, I'm passing this. I have enabled ingress. Now, if I use this values file, based on these changes, the template will be deployed. Now, how can I install using this values file? Right? I can use Helm install Java web app, your release name, your chart name. What is your chart name? Your chart name is, this is your repository name, which you added, Mithun Tech. Inside that, you have this chart and values file. I have changed the values file. I can use something like this, hyphen. I have taken the values file, right? I can use this option, hyphen F. Now, one second. So name, there is a issue, right? So now I can upgrade because I already installed. While installing, there was an error. So I will upgrade this one. The deployment is failed because there is a issue. There is a issue with this one. So the Helm deployment is failed. Now I can upgrade instead of install. or I can remove and install, whatever you want to do. Helm, uninstall this one, then you can install or you can upgrade. Now if you see, now lot of things got created. Helm, ls, the application is deployed. Now if you see, Helm, you can see kubectl get HPA. So this time do you see HPA got created? And do you see the ingress got created this time for this? Do you see ingress got created? Now, similarly, your deployment got created. Your deployment got created. So you can play with values at runtime. Now, if you guys have to deploy this application, what you can do, guys? Do I need to share this chart manually, the tar file? Suppose you want to deploy this application in Kubernetes cluster. Do I need to share this tar file manually, or you can add the repository? You can add the Helm repository. What you can do, you can add something like this. You can add a repository, something like this. If you have installed Helm, right? If you already installed Helm, can you execute this command? And then if you want to customize values, you can take something like this. You can take something like this. And you can deploy something like this. Or if you want to see what are the templates is part of that chart, I can execute something like this, guys. I want to see, if you see I don't have that templates, I have not downloaded locally, but still I can see what is part of that chart. Helm, show templates, your chart name. Inside that you have a chart name. Sorry, Helm, just a template. Now, if you see, I want to see what is there as part of this one, right? It is going to show what are the things it is going to be deployed. Suppose after customizing, if you want to see, you can use that values file. If you want to see with this values file, what it is going to be generated, what it is going to be deployed. Now, if you see now, ingress is getting created. Ingress is getting created. If you see, ingress rules are getting created. Then HPA is getting created, horizontal pod autoscaler, because I have enabled horizontal pod autoscaler. You can see this is getting created. And your pod, your deployment file, liveness probe, readiness probe, resource request limits. So you can use Helm to deploy the applications in a Kubernetes cluster. Helm simplifies the process of creating and deploying the applications in a Kubernetes cluster. Similarly, using Helm, we can install third-party application also in Kubernetes if there is a chart available. What is third-party applications here? Like the application which is developed and maintained by some external people. Now, I can install lot of applications, third-party applications, like I can install Prometheus, I can install Grafana, or I can install ELK stack, Elasticsearch, Logstash, Kibana. These are like third-party applications. We can install these applications also using Helm chart if the chart is available. So now we will try to discuss about what is Prometheus and Grafana. Then I will show you how can we install Prometheus and Grafana using Helm chart. But before going to install Prometheus and Grafana, we need to understand what is Prometheus and what is Grafana. So first we will try to discuss, then we will install Prometheus and Grafana, guys. Do you guys have any questions on the Helm chart, whatever we discussed? If you have any questions, feel free to ask in the chat box. You have any questions on the Helm chart, whatever we are doing? How can we create a config map and secrets, right? If it is not there, you just need to create. What you can do, you created a Helm chart, right? If it is not there as part of this, right? What you can do, when you create this one, Helm create, you created a chart, it will generate only some standard directory structure and files. If I want to create a config map and secret, you have to create first something like this. You create a file, config map.yml or secret.yml, whatever it is. Then you have to write on your own API version, kind, secret or config map. If it is not there, you can write your own metadata, something like this. Data, but here you can define values, you can refer values from values file. So username, and you can refer values from your values file. Dot values, right? Something like this. Something like this, database, username, right? You can refer from a values file. At runtime, you can control with this values file, right? So something like this. If you see the way you are referring the values here, right? The way you are referring values here, while in the image, right? Something like this. So now what I can do there, I have created a config map as part of the template. Now in my values file, I can define that. It is just generating some predefined files, predefined values. On top of it, if you want to add, you can add So now I can add something like this. That something like this. DevDB. Now let me generate. If you want to test the syntax, you can test using this. Okay, in my what I have referred in that config map, okay, I am referring DB username. Right? In my values file, this is what I have to refer. Test templates at values.db username nil pointer evaluating interface. Let me, I have done some mistake. So V is caps, guys. Here. Now, if you see, when I try to install, right, it will take the value from that values file. If you want to see the template, Helm. Now, can you see that config map also now? When I install, will it create a config map also now? So if whatever is not there, you can create on your own, and you can use templating language, right? You can, if you want to, if you don't want to override this value, you can refer from a values file. At runtime, I can change. Suppose DB username. When you are using same Helm chart for a production, do I need to modify my YML? Do I need to modify my template? Or can I pass at runtime? If same Helm chart, if I want to deploy in a production environment, if I say something like this, now what value is taking? Do I need to modify my templates for each and every environment, or can I play with the values? So you can play with the values. Now you can see whatever I pass at runtime, it will take. This config map you can refer in your deployment, in your pod manifest if required. Here you can define environment. You can refer from the config map. Guys, clear how to use Helm charts? Then we'll try to understand what is Prometheus, what is Grafana. So first we'll try to understand theory part. Maybe we will try to deploy the application, Prometheus and Grafana application, once we understand what is Prometheus and what is Grafana. Prometheus is basically an open source monitoring and alerting toolkit. It's a monitoring software. Prometheus is an open source open source monitoring and alerting toolkit. Prometheus consists of several components. Prometheus consists of several components, like Prometheus consists of several components. We will try to understand the architecture. Prometheus architecture. So this is your Prometheus software. Let's assume you are trying to install Prometheus. You need to understand the component of Prometheus. It's a monitoring toolkit. Prometheus has several components. Prometheus has several components, something like this. Alert manager, right? Prometheus will have at high level, there are several components, guys. Prometheus is an open source monitoring tool which consists of several other components. So Prometheus is a monitoring and alerting toolkit, which will have a lot of components. What Prometheus does basically, Prometheus will scrap the data. What is the meaning of scrap here? What is the meaning of scrapping here? It is going to collect. Prometheus server is going to collect the metrics, the data, and it will maintain that data. So Prometheus will collect the metrics. So suppose I want to monitor a lot of things, right? I want to monitor a server, or I want to monitor a Kubernetes cluster, or I want to monitor some application, right? So this is my server. Server 1, server 2, or I have a Kubernetes cluster to monitor. I want to monitor Kubernetes cluster, Kubernetes API server. So these are my servers or my applications. Or I want to monitor some application. So if I want to monitor servers, or if I want to monitor my Kubernetes cluster, or if I want to monitor my application, right? Using Prometheus, I can monitor. These we call it as a targets, Prometheus targets, right? I want to monitor these things. I want to monitor a server. I can monitor servers. If I want to monitor Kubernetes cluster, I can monitor Kubernetes cluster also. Like whatever is going to happen in a Kubernetes cluster, I can monitor. And if I want to monitor application also, I can monitor. So Prometheus will pull the metrics. So Prometheus will have a exporters. There is a concept called exporter, Prometheus exporter. If I want to monitor some server, I need to have some exporter in this. If I want to monitor Kubernetes cluster, I should have some exporter in this. If I want to monitor some application, I need to have an exporter in for this application. We need exporters. What is the role of exporter here? Prometheus has a lot of exporters. We call it as agents. Prometheus exporters are nothing but agents. This exporter or this agent will gather all the information from this server. This exporter will gather all the information from this server. This one will gather all the information about your Kubernetes cluster, right? This one will gather all the information about this server, this application. So Prometheus is a monitoring software. What monitoring we are doing? Your server monitoring, your application monitoring, right? So Prometheus will collect the metrics from all these things. Suppose if I want to monitor some server, I need to have some exporter here. There are a lot of exporters. Suppose if I want to monitor server information, what is the CPU utilization of the server? What is the memory utilization of the server, right? What is the network statistics? So if I want to monitor server, I should have one agent here. We call it as a node exporter. We call it as a node exporter. If I want to monitor server information, I should have a node exporter. Suppose if I want to monitor Kubernetes information, I want to gather the Kubernetes information, like how many deployments are there, how many pods are there. I want to monitor Kubernetes cluster. Here we need to have some exporter. We have some exporter called kube state metrics. This is one exporter. So there will be some exporter to monitor your applications like Java application or .NET application. Application exporter. Excuse me. So you should have exporters here, and you have a Prometheus software. This Prometheus will pull the metrics. This guy only will connect to this exporter. These agents will not push. This Prometheus only will connect to all these things. This Prometheus only will connect to all these agents, and it will gather the information. So this Prometheus will have one file called prometheus.yml. As part of this software, you have your one file. In this file, you are going to define all the information. What are the targets what are the targets of this Prometheus? From where and all it has to pull the metrics. That information is part of your prometheus.yml file. When you install this Prometheus software, you can provide a target information, this node exporter, in which server it is running, what is the server, on which port this node exporter is running, right? So this guy will connect to this exporter and it will gather the information. This guy will connect to this one and gather the information. It will connect to this one and it will gather the information. So it will maintain all the information in a time series database. It will maintain in some database internally. And we can create some rules. Once it gathers the information, we can create some rules, alert rules. There will be a rule engine. We can create some alert rules. I can define the rules also. What is my rules? Suppose if server is down, node is down for 5 minutes. If node is down for 5 minutes. If node is down for 5 minutes, right? Suppose it is trying to contact this guy and this node is down. So this node exporter will not be reachable. If this server itself is down, this guy cannot contact this target, right? If this node is down for 5 minutes, we can trigger an alert. This Prometheus will trigger an alert to the alert manager. It will trigger the alert. It will trigger an alert to the alert manager. I can define my alert rules. If node is down for 5 minutes, or if CPU utilization is greater than 80%, these are rules. Or if memory utilization is greater than 85%, I can trigger alerts. I can create alerts based on the, we can create alert rules based on the data these exporters are sending. I can trigger alerts, I can create alerts based on the data these exporters are sending. Whenever this condition is satisfied, Prometheus will trigger an alert to alert manager. What alert manager does, excuse me. Alert manager can send an email, it can send an alert, it can send an email or Slack notification, or pager duty, right? So it can trigger alerts. So this is the heart of monitoring. Prometheus is heart of monitoring. This Prometheus is trying to collect the data from the exporters. The data will be maintained and we can create alert rules here. Whenever the condition is satisfied based on the data it has collected, the Prometheus will trigger an alert to the alert manager. In the alert manager, you can configure your SMTP details or your Slack details. So whenever this Prometheus will trigger the alert to the alert manager, this guy will send an email notification, Slack notification based on the data, based on the alert rule we have created. So there are a lot of components. Suppose I want to see the metrics in a nice dashboard. Prometheus doesn't comes with a very nice UI. So for that one, you have to deploy one more application. If you want to see in a nice visualization, in a nice dashboard, I want to see the data. What is happening in real time? What is happening in my servers currently? What is happening in my Kubernetes cluster currently? I want to see in a nice dashboard. Prometheus will not have a nice dashboard. We can deploy one more application. We can deploy one more application called Grafana. This is different application. So Grafana is a visualization tool. So Grafana will again connect to the Prometheus. Grafana will connect to the Prometheus and it will gather all this information and I can see in a nice UI, nice dashboard. So when I try to deploy Prometheus, there are a lot of components in it. Prometheus has a exporters. We have to have a exporters in your actual machines, right? And the alert manager, right? It can trigger the alerts, email notifications, Slack notifications, right? And you can see in a nice dashboard. Okay. So you have all these options when you are trying to monitor your applications. So if I want to deploy this one, can I deploy this one without Kubernetes? or always, I have to deploy within Kubernetes? Can I deploy? This is one software, guys. This is one software. This is one software. Alert Manager is one software. Node Exporter is one software. Suppose I am not at all using Kubernetes. Can't I use Prometheus and Grafana? We can still use Prometheus and Grafana. What you can do? What you can do? In one server, you install Prometheus software. In your actual servers, you install your node exporters and you give that information here so that this guy will talk to the exporters and it will get the data. And you can install Alert Manager in a same server or a different server, and you can install Grafana in a same server or different server. But if I use Kubernetes, can I use images? Can I deploy all these things as a containers? If I use Kubernetes or Docker, can I deploy this software as a container? Can I deploy this software also as a container? Can I deploy this software also as a container? So Grafana can be configured with any other monitoring tool. Grafana supports lot of backends. Grafana can connect to the InfluxDB, Grafana can connect to the Graphite DB, or Grafana can connect to the Prometheus. Right? Grafana is individual, altogether it's a different tool. It can connect to the any monitoring software and it can gather the data. So we can deploy, if I am using Docker, if I am using Kubernetes, I can deploy these softwares as a containers. Now, if I use Kubernetes, what needs to be done? If I want to deploy Prometheus, what needs to be done for Prometheus? Can I, we have to deploy it as a basically we have to deploy it as a what? We have to deploy it as a pod. In Kubernetes, we have to deploy it as a pod. Can we directly deploy the pod? Is it, can we directly deploy the pod in a Kubernetes? No. So I have to deploy it as a deployment. Prometheus, do I need to deploy it as a daemon set, guys? Do I need to have a Prometheus in each and every node? Do I need to deploy Prometheus as a daemon set? Do I need to deploy in each and every node? Not required. I don't need. Prometheus is just one software. I just need to have a maybe one copy. For high availability, I can have a maybe 2 copies, 2 replicas. The Prometheus software I no need to deploy as a daemon set. But what I have to deploy as a daemon set? I want to monitor each and every node in my cluster. I have to gather the node related information. What I have to deploy as a daemon set? The exporter, node exporter. The node exporter, I have to deploy it as a daemon set. So, since I am using Kubernetes, I no need, I no need, sorry guys, I no need to provide the IP address of this server or pod. It can use service discovery, service concept. It can gather the information using the service. And since I am using Prometheus to gather all the information, Prometheus will have some data internally. What else I need, guys? For my Prometheus application, I am trying to create it as a deployment, or maybe I am trying to create it as a stateful set. Do I need to use volumes? What is the problem if I don't use volumes? What is the problem if I don't use volumes? Whatever data it is gathered, whatever data it is scrapping from the exporters, whatever the data I am getting from the exporters, right? If I don't use volumes for this one, for some reason your Prometheus is gone and your Prometheus pod got recreated. So what is the problem? What else I need to use for Prometheus application now? Do I need to use a volume or we have to use a values? For some reason, if Prometheus is down, whatever value, you can use EBS, you can use NFS, whatever value. And I need to deploy alert manager also. Do I need to have alert manager as a daemon set or just I can have as a deployment with single replica? Do I need to have alert manager as a daemon set? Do I need each and every node has an alert manager as a deployment? And what about Grafana? I have to deploy all these components together. All these components together. So, first of all, why we need to do monitoring? What is the advantages of monitoring? What is the advantage of monitoring? So, enterprise applications are looking to decrease the downtime and optimize your resource utilization. Enterprises are looking for decreasing the downtime and optimizing the resources. So we can do a server monitoring. Server monitoring is a way to look into what your servers are doing in real time. Server monitoring is going to provide a way to look into it, what your servers are doing in real time, what is happening inside your servers as of now. It can provide some actionable data. Like it will provide a network information, machines like CPU and memory utilization, what is happening, right? You can monitor your application. Right? So if we monitor our servers, we are going to have a lot of advantages. We can increase the uptime. We can improve our hardware and software performances by looking at what is happening at current time, right? And you can observe some trends. At what time I have a lot of load, at what time I have a lot of load on my application or a lot of load on my servers, right? If something went wrong, you can analyze what is the CPU utilization, what is the memory utilization when the issue has occurred, right? So you can analyze your whatever information is gathered by the Prometheus or Grafana, right? So this is the architecture which we already discussed. We have a Prometheus server which will gather the information from the exporters. We call it as a targets. It will pull the metrics and it can pull the server, the Kubernetes related information also. And we can create alerts so that alerts will be triggered to alert manager. And we can use Grafana to visualize the dashboard, right? So all this information we can define in a Prometheus server. While deploying a Prometheus, we can define what are the targets, what are the alert rules, right? All this information. So if I want to deploy this one, right? If I want to deploy this one, I can deploy in a normal servers also, or I can deploy in a Kubernetes also. If I have to use Kubernetes, I need to write a lot of YML files. I have to write Prometheus, deployment file, volume file, service file, config maps, secrets for Prometheus. For node exporter also I have to create a daemon set. For Grafana also I have to create a deployment file. For alert manager also I have to create a deployment file. So it's very complex application, right? I have to write a lot of files, something like this. I have to write lot of files. Let me show somewhere I am maintaining that. If you see, I have to create lot of files. If you see, each file has like lot of lines, right? I am creating a cluster role. I am creating a config map. So if you see that Prometheus.yml, I am passing at runtime. That Prometheus YML file, I am passing at runtime to my deployment. I am creating a config map. This config map is being used as a value, right? Here I am defining what needs to be monitored. If you see, there are a lot of files which we need to create. If I use manifest file, instead of using this way, I can use it as a Helm chart. I can deploy this application as a Helm chart. Already Helm charts has been available for Prometheus and Grafana. If you see, already there is a Helm chart available for Prometheus. There is Helm chart available for Grafana. So I can use these Helm charts to deploy these applications in a Kubernetes cluster. So tomorrow we will see, we will deploy Prometheus, we will deploy Grafana, and we will see, how can we trigger a alert, right? What is Prometheus? What is Grafana? How to, monitor, right? Tomorrow we'll continue, guys. Tomorrow we'll continue with deploying Prometheus and Grafana in a Kubernetes cluster. And, we will see what and all informations it will be monitored. Okay. And how can we create alert rules? We will trigger a email alerts based on some metrics. We'll continue tomorrow, guys. I will share this document. Try to go through it once. We'll continue tomorrow.